Hello, everyone. Welcome to the Mr. Math Experience. Today, we're presenting another episode of Homework Help. We will be talking about average rate of change, which is the same as of the slope. So let's just start. We're going to do a couple exercises right here. Okay, so we're gonna work on the even exercises. Okay, so we have a table here with years and enrollment. This for a middle school, and question number 2 says find the rate of change from 2008 to 2016. So this is giving us where to go, right? Let's test this. Yeah, that's good. So it's going from 2008 to 2016, and these are the values. So if we read this table as the values of x and y, okay, so we know here are our coordinate pairs. Also, it's asking for the rate of change, which is just the slope. And also, let's remember, our slope is equals to the differential or the delta on y, the change on y, divided by the change on x. So how do we calculate the change of y? We just take the current number minus the previous one, which will be 1302 minus 1124, and all this divided by the difference here, right? We'll have 2016 minus 2008. So this is the rate of change, which is the slope. So let's calculate this. This is equals to 1302 minus 1124 divided by, okay, this is 22.25, and that should be the answer for the rate of change from 2008 to 2016. It's 22.25. Okay, let's continue. Now, for this question, we have an average price of gallon of gasoline. Again, these are years and these are prices, right? Again, how are we going to treat this? We're going to treat as x and y, and it's asking us find the rate of change from 2004 to 2010. So our first value is going to be here, 2004, right? And how this changed to 2010. Take a clear look here that it doesn't is not changing just 1 year. Okay, is actually 6 years what is changing. So this rate of change is basically how much did it change each one of those 6 years. Again, we're gonna relate. We're gonna treat this as the slope, which is the rate of change, the change on y divided by the change on x. So the change on y here will be this 302 minus the previous one, 3.02 minus 2.32 divided by, now I have to do the same for the years, 2010 minus 2004. Okay, my slope should be 3.02 minus 2.32. That is, make sure we're doing right, 3.0202 minus 2.32. That is 0.7. Okay, let's do the division. 2010 minus 2004. This is 6. 0.7 divided by 6. That should be 0.1166. So these are basically cents, right? Basically, it changed around 12 cents per year. Okay, that should be the rate of change in here. Okay, let's make sure. Let's verify that the values are correct. 3.02 minus 2.32, and this is divided by 2004. That works. Okay. Now, next question, question number 6. It says find the rate of change from 2012 to 2015. So this should be the next one. Should be here, right? Exactly the same concept. We have the slope, which is the change on y, divided by the change on x. The change on y will be 2.45 minus 3.64, okay, over 2015 minus 2012. So look, pay attention that on 2012 was 364 and on 2015 was 2.45. So which means that actually this rate of change should be negative, because between these last 3 years from 2012 to 2015, actually this price of the gallon of gasoline was decreasing. Okay, so our slope should be 2.45 minus 3.64. There is where this negative number gets created, divided by this 3 years, right? 2015 divided by 2012, and this is negative 0.3966, basically 40 cents. Okay, that is the rate of change from 2004 to 2010 and the rate of change from 2012 to 2015. Okay, let's continue. There are like several exercises we need to work on. Okay, that is 6. Let's go to 8. Okay, that's a battery life of a laptop each hour after unplugging. So look at the rate of change our difference in here, because it's not a straight line. So whenever we have a line, in the equation of the line, the slope is exactly the same. That means that the rate of change remains the same along the entire line. But in this case, there are multiple inclinations, so there are multiple slopes. It's not continuous. Well, it's a continuous, but it's not a straight line. Okay, it says find the rate of change from 2 hours of use uh, to 2 hours and 30 minutes of use. Okay, so basically we're on this point. 2 hours of use from here to 2.5 hours of use to here, 2.5. Okay, so we're going from this point to this point. So again, the slope in here, or the rate of change, the change on y divided by the change on x. So on this case, we're not subtracting, we're not using the values. What we're gonna do is just see what are those values. So let's look up that on 2 hours the battery life is 70. Okay, and in 2.5 hours the battery life is between 30 and 50, and this is increasing by 10, so it should be 40. Okay, the percentage. And there's half an hour, which is created by this 2.5 minus 2. Okay, hold on. There's a change in here. This is decreasing. So the one that matches with the 2 with 70 should be 2 minus 2.5. Yes, because it's decreasing. Okay, so there should be 30 divided by negative 0.5, which is negative 60. That is the rate of change. It's changing negative 60% per hour on this specific, this specific frame here. It's changing a negative 60% per hour. That's why on half an hour it changed 30% from 70 to this point on 40. Okay, so there should be negative 60%. That is what is changing on this battery lifetime. Okay, let's continue. Okay, we have exercise 10 and 12. Exactly same thing, is not on a straight line. So let's see what it says. Stefan recorded the number of miles that she ran during various days in September. Okay, so here are the days and here are the miles. Okay, what is the rate of change in miles run from September 6th to September 15th? September 6th over here, right here it should be my point, to September 15th. So look, every two squares here represent 6, so one square should represent 3. So 12 plus 1 square, that is 3, that should be the 15 in here. So my other value is here. Okay, another way that is super easy to work on this point in here, okay, I'm gonna call it point A and point B. Okay, my point A, it should be, the coordinates should be 6 4, and my point B, the coordinates are 15 6. Okay, if I call this one my point 1 and my point 2, okay, the point 1 should have the coordinates x1 y1, the point 2 x2 y2. Very simple, right? If I call point 3, the coordinates should be x3 y3. Okay, and another way how we can read the slope, we know that is the delta y divided by my delta x, the change on y divided by the change on x, is by y2 minus y1 over x2 minus x1. Now that we have the points, it's very simple, because y2 should be 6 minus y1 is 4, x2 is 15 minus x1, that is 6. This should be 2 over 9. So the rate of change is 2 over 9, whatever that fraction is, miles per day. Okay, and number 12, it says, what is the rate of change in miles run from September 18th to September the 21st? Again, the change in here, I'm going to try to zoom in a little bit. The change in here that is going to happen, let's take a little bit less thickness in there, is from here, from the 18th, let's change the color, from here to this one here, right? Because remember, each square measures 3 days, so this should be 21, and is asking me from September 18th to the 21st, so it's right here. Let's take again this point. We're gonna call again this point A and this point B. It doesn't matter how do you call it or what do you call it, as long as you write the actual coordinates. Okay, so that being said, we have a point A that is 18. This point here is going one by one, 1 2 3 4 5. So it should be 18 5. What about the point B? This point B in here should be the 21 on x, and this should be 9. And we apply exactly the same formula. The slope is equals to the differential on y divided to the differential on x. And the differential on y is also known as y2 minus y1 divided by x2 minus x1. We know if we call, it doesn't matter what points we call point 1 and point 2. If we call this one point 1, so these are coordinates x1, y1. If we call this one point 2, this one here will be x2, y2, and then we just replace the values. So y2 is 9 minus y1 is 5 over x2 is 21 minus x1, 18. This should be 4 over 3, and that is the rate of change. I'm going to try to move this a little bit. Okay, now that's better. So we can write our answer. x1, y1. Okay, and so my rate of change is 4/3, which is 1.3333 miles per day. So remember, it's not the same slope along the entire graphic because the lines are different. It's not just one straight line. Okay, let's continue. We got 14. It says a car worth 27,500 in 2012 uh, is worth 16,720 in 2016. Find the rate of change in the value of the car. So it's logic, right? 2012 we have one price, 2016 we have a different price. So if we check the previous exercises, we can build our own table, or at least think into the same concept that we have the years on X and the values on Y. So we're going from 2012 times is increasing 2016, but what happened with the values? First value is 2700 27,500, and the second value is $16,720, which is, it's making sense, right? It's making sense that the more time, the less worth, or the less value for the car. So again, the rate of change, one more time, is the same that the slope. In order to calculate the slope, we calculate the differential on y divided by the differential on x, or also called the change on y divided by the change on x. So if if we check this, so from this point we want to see how did it change, right? So we're gonna have $16,720 minus 27,500. So the question here, well, then we have to subtract 2016 minus 2012. Something else to think in here. Um, are we expecting this rate of change to be positive or negative? Hmm? What do you think? The rate of change will be negative because the value of the car is decreasing. Okay, so something, when the time is passing, something is getting subtract to the value of the car. So let's process this. It says 16,720 minus 27,500 divided by, oh, again, 16,720 minus 27,500 divided by 16 minus 2012. So on this 4 years, on average, each year, the rate of change on the price of the car, or the value of the car, is negative $2,695. Okay, perfect. Now let's continue. I don't know how many more. I think we have two more. Okay, let's go to this one, 16. Which is did 14? Yeah, 14 is done. So 16. It says the Boston Red Sox had 949 runs in their 2004 season. In their 2015 season, they have 748 runs. Find the rate of change in runs. So 2004, 949. Time is passing, 2015, and we have less runs. So we are expecting a rate of change that is negative. Again, let's build our own table. We'll have the year, we're assigning X, and the values for Y. Have 2004, 949 in their 2004 season, and what happened in 2015, 748 runs. So look how it's changing this part, the Y that I'm calling the runs. Okay, so the change on the years of 9 years, it has decreased the runs. So let's see, let's calculate again. The slope, which is the same that the rate of change, will be equals to the change on y divided by the change on x. So my change on y will be the 748 minus 949. And we do the same for the years. 2015 minus 2004. Okay, let's solve this. This is negative 18.27 runs per year. Remember, it has been 9 years. Okay, let me check if all my numbers are correct. 748 minus 949 divided by 2015. Yeah, 18.27 times 9 plus 949. Okay, um, let me make a double check in here because I think one of my numbers is off. I'm subtracting 748 minus 949, 2015, 2004. Yeah. Oh, I got it. It's 11 years. No, everything is correct. No worries. Yeah, perfect. Everything's good. Okay, let's continue. There's always a good point to check. After I complete the exercise, I always need to kind of go through it and check and make sure that everything is working good. I just don't want to. I'd rather to correct something than saying everything is right and it was not. Okay, so Drew measured the snow accumulation during a snowstorm. After the first hour, 2 inches had accumulated. After 6 hours, 3 feet had accumulated. Find the rate of change. Okay, so again, exactly the same. So we're gonna call to x our time in hours, and our y will be of our inches of snow. Okay, after the first hour, so in the first hour, number one, we have 2 inches accumulated. And after 6 hours, we have 3 feet accumulated. Okay, so my slope, which is my rate of change, will be the change on y divided by my change on x. My change on y, we already saw this, will be this 3 minus this 2. And my change on x will be this 6 divided by this 1. I'm sorry, subtracted that 1. So we will have 3 minus 2 over 6 minus 1. So we'll have 1 over 5, which is 0.2 inches of snow per hour. Okay, thank you so much for watching. Remember, subscribe to our YouTube channel. You can always text your questions. You can follow us on our social media: Facebook, Instagram, TikTok, and visit the website www.gomistermath.com. We will be glad helping you. Thank you so much.